Today I am going to start with trigonometric ratios. Like many people get confused and how to try to remember these things. But I will say a simple suggestion or a trick, you can call it as, that always try to consider a right triangle. We know that trigonometry is nothing but in a right triangle, you will try to find the relation between the sides and the angles, the acute angles. So this is something similar to a magic, like how you might be thinking how sides are related to angles in a triangle. So let us see how. So consider right triangle. Consider right triangle. So this is a right triangle, and I call it as simply naming. Many people get confused with the naming convention. I'll keep angle as, for example, theta, simple, and also this angle I will consider theta. This is 90 degree. This angle, as you know from angle sum property, sum of all the angles in that triangle is 180 degree. So it will be 180 minus 180 minus 90 plus 90 plus theta. So this is equivalent to 90 minus theta. So this is angle. But now I am not going to consider on this one. But for example, if I take this as angle theta, this is 90 degree, and let this side opposite to angle, well, theta called as opposite. I will write opposite as OPP, and the side adjacent to this angle theta is adjacent. Now you will ask me why I didn't name this as adjacent, because there are two sides which are adjacent to theta. But since it is a right triangle, the longest side, we call it as hypotenuse. Let I name it as HYP. Let it be like this, only three letters, I am shortening it. So then you will understand why. So theta. So now I am going to define the angles, ratios, sine. So first I'll start, this order is important to remember. Sine of theta is defined as the opposite side, ratio of opposite side by hypotenuse. So similarly, I can define cos theta as adjacent by hypotenuse. And also now what is important is these two. If you are very clear with these two ratios, sine and cos, and as you see that if you are very clear with only sine, if you don't get confused with either sine or cos, if you remember this, the other things are very easy. There are so many ratios like sine, cos, tan, cot, and cosec and sec. So I am not going to say all these things, but if you remember these two, it is sufficient, and I am going to say why. But this is later on. Now coming to simple identities, I am going to start with exercise 8.4. So I will start with simple identities now. Like for example, I can consider that sine square theta plus cos square theta is equal to 1, this identity, and then 1 plus tan square theta is equal to secant square. So you can we can clearly observe that now you will ask what is tan and sec. Now consider that tan theta. Tan is a tangent. We call short form for tangent. So tan theta is equal to uh, sine by cos. Sine theta by cos theta, which is equivalent to opposite side by adjacent. So similarly, inverse of tan is cot. Cotangent cot is equal to 1 by tan, which is equivalent to again in terms of cos theta by sin theta, I can write equivalent to cos theta by sin theta is equal to adjacent by opposite. So I will suggest you that remember only sin theta and cos theta. Other things are much simpler after this. So similarly, I can go for secant. What is secant? Before that, cosec. Cosec theta. Cosecant theta is equal to 1 by sine theta. Similarly, secant is equal to 1 by cos theta. So this is how you have to read the ratios rather than trying to cram everything. It is enough that you understand what is sine theta and cos theta. And now I am going to say how to remember the table. There is a shortcut to remember the table. So how to remember the table? You know that we will start generally by sine theta. One moment. Sine theta. Let this be down. This is sine theta. And the theta values will start from 0, then 30 degree, and then 45, then 60, then 90. We are concerned with only 0 to 90 degree. So sine 0 is 0. I will start with derivation in other video, but I want to quickly summarize because I want to solve exercise 8.4. So sine 0 and sine 30 is nothing but 1 by 2. Then 45 is 1 by root 2. 60 is root 3 by 2 and 1. As you can see that sine theta value starts at 0, then increases to 1, going from 0 degree to 90 degree. So this you have to, this is a observation. You can call it as observation that sine theta value from 0 to 90 degree, it increases from 0 to 1. So at 30 degree it is 0.5. At 1 by root 2, 1 by root 2 it is 1 by root 2 is point something 0.707. So root 3 by 2 you can calculate it. So this similarly I can say that if you remember this sine values, and I will show the derivation also later on, how to derive the formulas if you forget in case. So these are values one have to remember. Sine 0, it will start with 0. 30 is 1 by 2, then 1 by root 2. Sine 60 is root 3 by 2 and 1. So if you remember this, I can write the table for all the other trigonometric ratios. I will show you how to write it. So now cos theta, just reverse it. So write like this: 1 root 3 by 2, 1 by root 2, 1 by 2, 0. So cos theta will vary from 1 to 0. It will reduce. So at 0 it will be uh, in between 0 and 90 degree. The cos value will be maximum, will be highest at 0 degree. So at 0 degree it is 1 and then it reduces to 0. Similarly tan value, it is signed by cos, so 0 by 1, 0 by 1 is 0. Similarly tan 30 is 1 by 2 divided by uh, root 3 by 2, it is 1 by root 3. 45 is 1 by root 2 divided by 1 by root 2, 1. Similarly sine tan 60 is root 3. In this manner, then it is undefined. Here it is undefined. Tan 90 is undefined because 1 by 0, anything you cannot divide by 0. Now again I can write similarly for cot theta. Cot theta is nothing but 1 by tan. So 1 by 0, again here it is undefined. So inverse it: 1 by root 3, 1, 1 by root 3, and 1 by undefined is 0. So now I can write again cosec. Cosec is nothing but 1 by sine. So this is again 1 by 0, undefined. Undefined I can write it. And so 1 by cosec 30 is inverse of 1 by 2, so that is 2, and root 2, and 2 by root 3, 2 by root 3, 1. So similarly I can write for secant value. Secant theta is equal to inverse of cos, 1 by cos. So it is inverse, means it is cos theta whole inverse, not cos inverse. So 1 by 1 is 1. Again it is root 3 by 2, so 2 by root 3, and then 1 by root 2, so inverse is root 2. Similarly again it is 2 and then undefined. So I hope it is clear how to write a table, because this table I suggest that practice writing it so that it will be much simpler. Only you have to remember the value of sine theta. It will vary from 0 to 1, and also I will teach you how to derive it in case you forget within 2 minutes. So this is the beginning, how to begin. So now, as I mentioned earlier, there are few so there are few identities in to solve exercise 8.4. Complementary angles are there. Complementary angle is nothing but write the heading: complementary angles. That is nothing but, if I want to find sine 90 minus theta, which we already did from the table, is equal to cos theta. For example, consider theta is equal to theta is equal to, let it be 30 degree. So cos 30 is equal to, we know that cos 30 is, recall from the table that cos 30 is equal to root 3 by 2. So now I am going to what is cos 30? According to this formula, we will write it is equal to sine 90 minus theta. So what is sine 90 minus theta? Sine of 90 minus 30. Theta here is 30. So this is equivalent to sine 60, isn't it? Sine 60. So I can I can say that this is sine 60, equivalent to sine 60. So this proves that sine 60 value, we know from the table, it is equal to root 3 by 2. So similarly, for others also it is applicable. Cos 90 minus theta is also equal to sine theta. So this I can write, and also I can write for others also similarly, tan 90 minus theta is equal to cot theta. This is very obvious from the table, and this is the reason why I first drawn the table. Now if you have any confusion, just look in the table, because if you don't believe these values, if I take cot 45, what is cot 30? Let it be cot 30, it is root 3. So cot 30 is root 3, and tan 90 minus 30, that is tan 60. Tan 60 is also root 3. So now it is very clear that this formula, this complementary angles, is very evident from the table. So this is a shortcut. Using this only, this formula only, I have written this, and also like inversing it. These are the tricks, simple tricks which makes life easier. So I'm going to continue with exercise 8.4 in next video. Thank you.